7 to 8 years now. So I'll just quickly start with a very, I would say, a lively topic, which is math beyond the classroom, finding math in the world around us. So I always say that math is everywhere around us, but today I would just like to bring few of the most common things where you can see mathematics in your real life. Along with, I'll try to explore, I will try to explain few of the activities which you can take in your classroom using low cost to no cost resources. So before I begin, I would just quickly introduce myself. Who am I? So this is me, a caricature version of me, and I am a daughter. I am a wife. I am a daughter-in-law. I am a homemaker. I am a researcher, and I am an entrepreneur. So I am just trying to balance it all. And I would just like to share with you my journey in a nutshell, obviously. So before 2009, I was a girl back then when I did not like math at all. And like any other child in a school, and that too at that age, like let's say 13, 14 years, I literally did not like math at all. But after 2009, everything changed. Like everyone has a turning point, and my turning point came in 2009 when I met one of the teachers. So whenever, if anyone says that in today's era, digital era, that AI will replace the teachers, that's never gonna happen, because my turning point came because of my mother and that one teacher who changed the way I looked at math before 2009 and how I looked at it after 2009. So this is how like ups and downs happened and my journey continued. In 2023, again, I began my entrepreneurial journey as well as my research journey. So both of them started parallelly. In July 2023, I started my research journey, and in April 2024, I launched my startup Beyond Chalk and Talk, which is working in the domain of mathematics, how pedagogy of mathematics and assessment of mathematics can be transformed in schools across India. So this is what in nutshell my startup is doing. So I'm transforming the pedagogy and assessment practices of mathematics in schools at foundational as well as at preparatory stage. So that is basically grade 1 to grade 5, where I do a lot of teacher training and a lot of other things. So let's move further, and I would just like to ask first, I would just like to bring to your notice what today's session is all about. So today's session, as the title, is finding math around us. So if you notice, right from the cooking to machine learning, AI, infrastructural development, everything is mathematics. No doubt about it that math is not present anywhere. No doubt that it's present everywhere. And I always say this thing, subconsciously, unknowingly, mothers, because they usually cook at home, no doubt that male members nowadays also cook, are the best cooks. So I'm not doing any gender bias over here. I'm just saying the one who is cooking is definitely good at mathematics, because as a child I was always amazed by my mother's art. Like, and everyone has it. Like you have to have let's say a dinner party or a lunch at your place of 15 to 20 people all together, and I was never able to understand as a child that how they can, like, कोई भी दाल भिगोना है, कुछ भी करना है, they are able to do it perfectly. I don't know how they did it every time, kabhi khana kam nahi padega, kabhi khana waste nahi hoga. They knew it everything. And if I just convert it into the language of mathematics, it's nothing but ratio and proportion. So in what ratio you are putting your masalas, your vegetable, everything, it's completely mathematics. Or if I talk about shopping, the biggest example is like you are getting a off season discount, or the complete cost price, selling price, profit and loss, everything happens like we have mathematics. And completely it's dependent on, like, shopping is dependent on mathematics once again. Or if I talk about playing games, entire coding, everything is related to mathematics only. So like you will just name it and mathematics will be there definitely. So now I would just like to put one poll. So I will just launch a poll, and the poll is: how many moments of math you experience today without even realizing it? So I have just given you few of the examples also, and it can be anything like it can be, you can write your answers in the chat box also. How many times you have looked at the clock, calculated travel time, counted steps. So you can just write a number over here, maybe none, maybe 1 2 3. It can be anything. So you can just I'll just launch the poll also. If I'll just see the option, Akriti, if you're here, can you please launch the poll? Because
Sure, ma'am. The first
yeah,
one?
yeah, please launch the first poll.
Okay.
How many moments of math have you experienced today without even realizing it?
Poll is live, ma'am.
Okay, 100% are okay. We'll just keep the poll on for another maybe 10-15 seconds. Quickly, everyone, you can please answer. I can see approximately 300 participants are already there. And 69% of the people are already saying more than 5 times. Okay. 3% of the entire audience is saying none. And 1 to 2, 29% of the audience is saying 1 to 2 times. Okay. So we have got more than half of the participants who agree that they have used subconsciously, unconsciously math in their daily life. And I was just asking about today. So yeah, so we can, I'm just ending the poll now. We have got a really good result. Now let's move ahead. I'll just move ahead and I will ask another question to you. And this is a very interesting question. And there is a story behind it also. One day I was just having a packet of chips, and that day I had a 30 rupees pack chips also and a 20 rupees pack chips also. So I just tried to prepare a question based on it. And you can later tell me in the chat box also that what are the mathematical concepts involved in it. Now, you just see how a simple pack of chips can have a lot of math in it. Like you can see on the right hand side of this screen, it's already written 20% more chips. But not going into the nitty gritties, I'm just going to ask you one question. Akriti, you can please launch second poll. Which will have more chips? 3 pack of rupees 20, which is shown on the left hand side, and or 2 pack of rupees 30. So price wise, you have spent the same money. I am asking, according to weight, what do you think? Which will have more chips? 3 packs of 20 or 2 packs of 30? I'll just keep the poll on for another 30 seconds and then I will end it. half of the participants have already answered. Just 15 more seconds and then I will end the. So 60% of the people are saying 2 pack of rupees 30. And approximately 41, 42 people are saying 3 packs of 20. Okay, that's really very interesting. So I have now ended the poll and I will just show you something. So if you just look at the backside of the chips, 48 gram like rupees 20 chips weighs 48 gram and rupees 30 weighs 67 grams. And I asked you that you have 3 packs of 20 rupees. How much that will weigh, I think you can calculate on your own. And how about this one, like 2 packs of 30? Most of the people answered that 2 packs of 30 will weigh more, but that's incorrect. 3 packs of 20 will weigh more. So this is 10 grams of chips you will get more if you are going to take 3 packs of 20 rupees chips than 2 packs of 30 rupees chips. So this is what, like, it's all about the perspective. You have to just find mathematics in your real life, and as in when you will just look around, you will see a lot of mathematics around you. Like in just just in just a packet of chips, you saw the concept of weight, you saw the concept of percentage. If I just ask you how much more weight is like 3 packets of 20 rupees having than 2 pack of 30 rupees. So this can be one of the questions for grade 6, grade 7 students. Ratio and proportion concept can also be covered over here. There are multiple concepts which you can cover in this particular thing. So that is what I wanted to share, and where my, like, this was one of the activity which I wanted to do with all of you. So now, this is another very interesting thing. So what I'm trying to do in this session is I'm trying to show you where you can, like, few of the things obviously, where you can see mathematics around you. Like these are very common things in which you will be able to see mathematics, like calendar. In every household, calendar is there. A pack of chips, and it's not necessary that you're only going to buy a pack of chips. It can be any thing. You can even look at the packet of atta. I haven't done the math, but you can just try to do that. Like it's a good way of teaching kids different concepts in your like from the items that are available in your household. So chips was just one of the example, but you can take any other thing. Now, if I ask you, you can write your answers in the chat box. Looking at this, do you see any problem with this calendar? 30 seconds. You can write your answers in the chat box, please. Do you see any problem in this calendar? Yes, that's right. Month names are missing. Name of the months are not there. Absolutely right. So everyone is going to answer that only because that's the only thing that is missing out here. But if I tell you there is a very interesting thing also, and which might not be easily visible to all of you, you can see that the months are not arranged in order. So let's say I actually built this. I have made this, and there is a very, like, I did a storytelling on this. Let's say a maid came to my room and she switched on the fan when I was just making this game. So what happened? I was just writing on. I made these 12 calendar cards, and I was just about to write the name on the chits. At that moment, my maid came and she switched on the fan, and all the like 12 chits flew in the air. Now, since I haven't written the month, I got completely confused which month is what, because now how will I know that which month is January, which month is February? In the same way, I've tried to create a digital version of it. You can see that all the months are arranged haphazardly. It's not that first is January, second is February, third is March. It's not like that. Now I am asking my children that you have these 12 cards with you. They are not in order. You have to arrange these 12 cards according to month. How will you do that? Any idea, anyone? From where we will get started and how we will proceed further? I'm sure you will be able to crack it. You can write your answers in the chat box, please. Yes, I'm already getting the answers, and that's absolutely correct. First month is February. So you can just quickly spot, you can just tell me first row, first column, something like that. You can tell me in the chat box that where is February. Yes, someone has answered it correctly that you have to check the next date and next day. So we will be coming on to that. So yes, February is the first month. You can see if I can just annotate. Yeah. So you can see that this month is February. Why this is February? Because obviously February is the only month which will have 28 days. If it is a leap year, it will have 29 days. But still, you will be able to identify whether it is February or not. So now February is ending on Friday, 28th Friday. So obviously next month is going to start with Saturday, and it should have 31 days. Why? Because March has 31 days. So we know that. So now we need to spot where is the month which has first as Saturday and has 31 days. So let's try to spot any answers in the chat box. You can please do that. Third one in first row. Yes, that's right. So I'll just annotate once again. Yeah. So yeah. So this is March. I'll just write March over here. And now you all know the drill. So I'm sure you will be able to spot April. April has 30 days. And how many, like where it's ending? March is ending on Monday. So there will be one only month which will start from Tuesday and will have 30 days. So let's try to find that month out. Yeah, I think I got it. I'll just see the answers in the comment. Oh, people are already ahead me. They are finding April 9th. One is April 10th. 8th is April. 8th is April. Are you sure? I think this one will be the April because March is ending on 31st. So April will be this month. I'll just highlight. This will be April because April is going to have 30 days and it will start from Tuesday because March has ended at Monday. So now Tuesday, this is done. Wednesday, it's 30. So we will now spot next month, which will be May. So May will again have 31 days and it will start from Thursday. So Thursday, 31 days. Where is that? Thursday, 31 days. This is the one. So you can see if you are just giving these random calendar, I have put the calendar of 2025 over here. You can put the calendar of any month you want and you can just take it ahead. So this is one of the activity which you can just do using an old calendar also. Do not throw it away. Just cut the strip of month, either vertical or horizontal, and just try to give it to your students and ask them to write the months at the back of it. So now I will move ahead. I am getting a lot of answers in the comment. I just wanted to change your perspective. I'm 100% sure you now can do it. Now I'll just move ahead. I'll just clear all my drawings, and this is the next activity. So I had a mirror at my home. I wrote few simple words like mat and gun. This activity works best when you will ask the kids or the students at the class to write their own name. It can be in uppercase, it can be in lowercase, and just put a mirror either horizontally or vertically and see which letters are reflecting. I remember this is one of the activities of NCRT as well. NCRT, I guess, like grade sixth book. But in that, they have given like M has mirror, like M is symmetrical, G is not symmetrical. So instead of asking the students to rot memorize, it would be better if you can show them the practical application of it, how it is getting reflected. So they can write anything. I have written mat as well as gun. They can write any words, and I have tried to show you both the ways. Like when I have kept the mirror like across the length as well as across the breadth. You can see G is distorted, N is distorted. Rest all the remains as rest all the letters remain as it is. So this is one of the very common activity, and you can't do it only with letters. You can do it with anything. Since we are discussing on a topic finding math around us, I would say you can even bring a leaf or a flower from your garden and then just see its reflection in the mirror. Is it getting reflected? Is it getting distorted? Is the pattern upside down? What is happening? Then only the students will get a real idea of symmetry, reflection, mirror image, because these concepts are really very abstract to the kids when they are like just looking at the textbook and trying to decode the math behind it. But when you do these type of activities with kids, it becomes really engaging for them, and at the same time they learn, and you don't even realize that they are learning. So this is one of the activity that I shared with you. You can try it at home. Just make sure that you are writing the letters, or like your kids are writing the letters little clearly. Even you can give them the printed sheets as well. That also works. And if the kids are at like grade 6, grade 7 onwards, middle school, you can just ask them to write your own name and then try this activity. Similarly, I did this at one of the schools in Pilani, where I developed the first mathematical park of India, which was sustainable. First sustainable math park of India for foundational and preparatory stage. And this is a very simple thing. I just requested their art teacher to just draw few of the things on the stairs. Like there was a specific park, which space which was designated for this mathematical park, and this was one of the activity out of 20 mathematical concepts that were demonstrated over there. So you can see what is happening over there. No cost is involved at all. Only the art teacher drew half of the butterfly or half of the kite on these stairs using various colors, and the kids are putting the mirror and they are looking at the reflection. So this can also be a very good activity for the kids to understand whether an object is showing symmetry or not, and they can even complete the pattern. This is a very good activity for pattern also, because if let's say like pattern starts from kindergarten onwards, like repeating pattern at least start. I'm not talking about the structural patterns or growing patterns, but yes, repeating patterns start. And if let's say I have drawn a circle, a triangle, and a square, now I'm asking that you have to extend the pattern. So if a child is not able to extend the pattern, instead of forcing or instead of directly doing the thing, what you can do is just put the mirror. and see if the pattern is getting reflected clearly or not, like it's correct or it's incorrect. You can even break the pattern also in various parts. Like let's say I'm saying circle, rectangle, square. If a child is a slow learner, you can put the mirror at, let's say, after circle and triangle, or maybe circle and square. So you can skip, like instead of the repeating unit as 3, you can keep the repeating unit as 2. So when a child will see the reflection, ultimately they will be able to understand that yes, this is how the pattern is getting repeated. One concept which we miss in our classroom is unit of repeat. After how many units the pattern is getting repeated, we directly jump to extend the pattern without even realizing if a child is aware of like repeating patterns or not, like unit of repeat or not. So that is one of the concept which you can really cover using this thing, like using mirror a simple mirror, and like whatever you can draw on the, even you can draw it using like paper, you can draw it using your, like on the blackboard, gray board, you can draw it using your colored chalks also, and you can just put the mirror and see whether it is getting reflected or not. So mirror is really versatile, and I use it in my uh, teacher trainings and in the workshops a lot, because it's really versatile and it covers a lots and lots of mathematical concepts. So this was another one that I wanted to share with you. Now this is really interesting, and if I ask you, like I need not to even ask you what these are. I am sure that everyone must be aware that what these are. First one is the logo of Mitsubishi, which makes cars, automobiles. So if I ask you, can you see math in these logos? Like every day we come across various cars on the street, or maybe visiting our favorite ice cream brand Baskin Robbins, or maybe drinking our favorite soft drink, which is really harmful also, cold drink, which is like you can see it's a logo of Pepsi, or let's say looking at the National Geographic, which is a yellow rectangle. There is a lot and lot of math involved in these things also. If you can please, let's start on a sweeter note from Baskin Robbins. Anyone, any idea what is the math you can see in the logo of Baskin Robbins? You can pour your answers in the comment box. We'll go step by step. Shapes and numbers, yes. Rotational symmetry, yes. Rakhi ma'am, no wonder the correct answer is coming from you. So, yes, Baskin Robin has, you can see if you look at 3-1, there is a hidden meaning behind every logo also. Since I know about Baskin Robin, I'm sharing it with you. No doubt that there is a rotational symmetry, but there is a rotational symmetry only when BR Baskin Robin is not written inside it. Then the rotational symmetry will be there at each angle because it's a circle. But you need to really check. That can be one of the very good activities for the kids later on. You need to check. You are just giving the logo of Baskin Robin to the kids, and you're just asking that at what angles rotational symmetry you can see in this thing, because it's, if it is written BR Baskin Robin inside, rotational symmetry is not going to come at each angle. So 31, pink color 31 that is written, it is showing that Baskin Robin has 31 flavors. So they have written BR in such a way that B is looking like 3 and R straight line is looking like 1. That means Baskin Robin has 31 flavors. No doubt everything has shapes and numbers. We'll just try to explore a little more than that. Now, if I just look at the logo of Mitsubishi, this is the logo I'm talking about, this one. We'll go step by step. What is the math that you can see in this? You can just write your answers, one concept only, because I know there are multiple concepts involved. One concept that you can think of in Mustabushi logo. Congruence, rotational symmetry, rhombus. That's right. Rhombus is the first and foremost concept that we can see in this particular thing, like this particular logo. We can just look at. Similarly, if I talk about the logo of Mercedes Benz, tell me what is the one concept apart from circle. What is one concept that you can see in this? Because we all know that it's a circle. Apart from that, what is one concept that you can see in this? I'm talking about Mercedes Benz, this one. You can just write your answers in the comment box. Triangular shape, equal division, fractions. Okay, so I'll just tell you that this has sectors. And if you notice, I'll just try to annotate. If you notice, it's getting divided from here, and it is divided into three sectors. Each sector is 120 degrees, and that's what is making into 360 degrees. It's not necessary that every like this shapes makes it to 120 degree as sector, but yes, Mercedes has 120 degree, three sectors making it to 360 degrees. Now let's move on to Toyota. So what do you think about the logo of Toyota? What is the math in it? I'm talking about Toyota, and then we'll quickly cover the next one also. Yes, someone has mentioned ellipse. So the logo of Toyota is made using three ellipses. Two of them are interlocked and one is the outer ellipse. So you can see a lot of math is involved in famous brands logos also. Similarly, the last two, the Pepsi as well as the National Geography, you can I'll just move on to the next slide, so that like golden ratio concept is involved over here. And you can see how like golden ratio is 1.618. Educators must be aware of it. Like you are just measuring two sides, and the ratio of it is coming out to be 1.618. So in 2008, when Pepsi changed its logo, it like just to make it aesthetically pleasing, it was used using golden ratio, which was one, like a by b equals 1.618. So again, a lot of math is involved in different like logos. You can also try to find few after this workshop is over. Like after the summit is over, you can also try to think few of the logos or anything else which has math in it. Now, a very interesting thing, why honeycomb has hexagonal cells. I'm sure everyone must be aware of it, but I'm just going to play a very short video and then we will come back to the discussion.
Incredible work ethic, the sugary sweet syrup they produce, and their intricate social structure. But another reason is that honeybees are, in fact, excellent mathematicians. Scientists claim that tiny insects can calculate angles and can even comprehend the roundness of the earth. But there's particular mathematical bee genius behind the most important aspect of honeybee life, the hive. Just like humans, bees need food and shelter to stay alive. The hive is not only the bees' home, but doubles as a place to store their honey. Since it's so central to survival, honeybees have to perfect the hive's architectural design. If you examine any piece of honeycomb, you'll see that it's constructed from tightly packed hexagonal or six-sided cells. Of all the possible designs, why do honeybees choose this one? To understand, you need to think like a bee. Bees need a secure place for their entire colony to live. Similarly, there needs to be a place where their nectar can be stored and ripened suitably until it turns into honey. That means there's a need for some serious space efficiency. A good solution is to build little storage units or cells just big enough for a bee to fit into, which can also double as the containers in which nectar is stored, the bee's very own honey jars. The next thing is to decide what the little cells should be made out of. Bees don't have beaks or arms to pick up things, but they are capable of producing wax. The thing is, producing it is a lot of hard work. Bees have to consume 8 ounces of honey to produce just 1 ounce of wax, so they don't want to waste it. So they need a design that allows them to store the largest possible amount of honey using the least amount of wax. What shape does that? Imagining for a minute that all bees had to attend Architecture Academy and go to math class. Let's say they asked their geometry teacher, what shape would give us the most space to store our honey but require the least amount of wax? And the geometry teacher replied, the shape that you're seeking is the circle, leaving the bees to return to their trial construction site and begin building their honeycomb using circular cells. After a while, some of them might have noticed a problem with their design. Small gaps between the cells. We can't even fit in there. That's wasted space, they might have thought. So, ignoring the geometry lesson and taking matters into their own hands, the bees went back to the drawing board to rethink their beehive design. One suggested triangles. We can use triangles, look, they fit together perfectly. Another bee suggested squares. Finally, a third bee piped up and said, pentagons don't seem to work, but hexagons do. We want the one that will use the least amount of wax and be able to store the most amount of honey. Yes, I think that's the hexagon. Why? It looks more like the circle than the others. But how do we know for sure? To find out, the industrious insect architects calculated the areas of the triangle, the square, and the hexagon, and found that the hexagon was, in fact, the shape that gave them the most storage space. They agreed on an ideal size and returned to work. The space-efficient comb that is a bee's trademark today is probably the result of this trial and error, but over long periods of evolutionary history. However, it paid off. Peek into any hive, with your protective goggles and netting on, of course, and you'll see the end result, a beautiful, compact honeycomb that any architect would have been proud to design.
So you can find this video on YouTube, and this is a video of TED Ed, and it's available on YouTube. I have mentioned the source over here. Trust me, if you will show this video to your students, their perspective towards surface area, perimeter, volume is definitely gonna change, and it will give them a real idea of how, if they are like combining shapes together, what is literally happening. They have used the shapes as circle, triangle, pentagon, square, and hexagon over here. You can ask them to use any other shapes also, but there is pure math behind it. Why honeybee chose hexagonal cells to store the honey, which we just had a look at. And there is a very interesting fact on this particular thing also. 1 teaspoon of honey is the work of 12 bees, right from right from the start to the end. Only one bee can produce 1/12th teaspoon of a honey in its entire life. So that's a fact also, and you can show them this video. A lot of math question can definitely be framed on this particular thing. You can just give them the sheets. You can ask them to try out why honeybee has hexagonal cells where they store honey. So Moving forward, this is very interesting thing, and this is the second activity of today's session. If I ask you, I would just request Akriti to please launch the third and the last poll. How do
Sure.
you generally teach prime or composite numbers to the students in the class? We'll quickly take this poll. You can write your answers on it. Just one-liner answers will work. How do you generally teach prime and composite number, which is a concept that comes in like grade 4, 5 onwards? Poll is on. You can just write your answers, or you can just write your answers in the chat box also. I think it's better you can just write your answers in the chat box.
Shall I stop the poll?
Yeah, I have ended.
Okay.
Different shapes. Sieve of eranthosis is one of the very common thing that we do, and it's kind of a game also. Yes. I'm just going to explain a different version of it through which you can just tell the students whether a number is a prime number or composite numbers, along with by counting factors. That's also right. I'm just going to tell that how they can just identify whether a number is a prime number or a composite number, along with whether the given number is a perfect square number or not. So let's try to see that. So I have considered two numbers over here, and trust me, it works with all the numbers. 23, and since we are talking about finding math in the world around us, I have tried to show you two real life things. On the left hand side, you will see bottle caps. On the right hand side, you will see paper pins. You can even use fallen leaves also. That will also work. Any material that is available and that is in quantity, you can use that, because bottle cap, I assume that it's a very common material. If let's say you are asking every child to bring two bottle caps, you will have 60 to 70 bottle caps. Similarly for paper pins. Now what you need to do, let's say you have given those many number of uh, like bottle caps or pins to the students, and you're just asking them to arrange in all the possible combinations. So here I have put few combinations. I'm sure there are many other combinations also possible, but I have just put few. But you will notice one thing in all the combinations, that in no array there is a complete rectangle or a complete square. It's missing. Here one cap is missing, here two caps are missing, here many caps are missing, one cap is again missing out here, one cap is again missing out here. So there are multiple things which are missing, like multiple caps which are missing in these combinations. That means you can just tell them, if you are on arranging different combinations, they can just arrange the combination. Best part, they don't need any paper, they don't need any pen, they have to just arrange it. If they are not getting any rectangle or a square, that means the number is prime. It works with any number you give them. If they are unable to form a rectangle, that means it's a prime number. Similarly, you will see on 36 what I have done. I have again tried to arrange them in few combinations. Everywhere, either I'm getting a rectangle or a square. If I'm getting a rectangle, that means it's a composite number. Here, at least 1, 2, 3 were missing. Here, you will arrange in any combination and you will at least get a rectangle, if not a square. Square, you will get in one arrangement only, which is 6 by 6. I have arranged it here. I'll just annotate it. For some reason, I don't know. Okay, so you can see my cursor, I hope, like 6 there and 6 there, this one. 6 here and 6 here. It might not look like a square to you at this moment because these are the pins, but when you will arrange it on like physical space, it will look like a square to the students, obviously. So that means if you are getting a square, it will definitely have a perfect square number. It will be a perfect square number along with a composite number, because there are many numbers which are composite but they are not perfect square. Like 24. 24 is a composite number because you will get at least one rectangle. All in all the arrangements you will see rectangle. But in 36, in 49, in 25, you will see a square arrangement, which means it will be a perfect square number also. So this is a fun activity for 6th, 7th, 8th class students, middle school state students, wherein you can just tell them to arrange the material that you have given them, find out different combinations, and you are able to see that the students can see the possible factors also. How they have to just look at the rows and columns. And once they are getting repeated, you can just ask them to stop. So these are the possible factors. So you can see using just one material how prime and composite numbers, perfect squares numbers, and the factors of a number, all three are getting covered in one game based learning activity. Now I'll just move to the last activity of my session, which is like I'm just trying to give mathematics a festive touch because festivals have already started. So, and again, in this, there is a very minimal material which is required, and the material is paper cup. So what I've done over here, I took a paper cup. Obviously, the image is, I used AI to make this image. And what I did, this is just a paper cup. You can consider a paper cup. And since I have considered it as 10 heads of Ravan, so what you can do is for considering 10 heads of Ravan, I've just tried to give it a festive feel by drawing like eyes and mustache and little bit of like crown on the head, so that it will look like a Ravan. And you can see 10 cups are placed. Another 10 cups are placed. On the first 10 cups, I have written random numbers. They are not in order. You can consider any numbers. If you want, you can consider numbers from 0 to 5. If you want, you can consider higher numbers also. All you need is 20 paper cups, 2 smiley balls. If you don't have a smiley balls, just try to create it from paper. From paper also, balls can be created. So all you need to do is just write the numbers on the paper cup. Just try to give them a little bit of festive feeling, like making 10 heads of Ravan, because these things really interest children. And just ask the children to throw the ball, just like bowling pins. Just ask them to throw your smiley ball or paper ball and see how many cups are falling. Either you can arrange them in 4, 3, 2, 1 order, like bowling pins, or you can arrange like this and just give them 2 to 3 chance. Let's say the numbers, the paper cups that are fallen are 3, 6, and 5 randomly. 3, 6, 5 are the paper cups that have fallen. And similarly, you have to ask the children for the second one also, wherein operations are mentioned. For younger kids, you can either put plus minus. For elder kids, you can just try to focus on all the 4 concepts, and you can try to increase or decrease the number of times add can come, multiply can come. So combinations you can decide on your own. Now let's say in 10 seconds, the child again threw the ball and he got, let's say, plus, multiply, and divide, let's say. Now what you need to do, you have to just ask the child in 30 seconds, in 40 seconds, just try to create the highest possible number. So he has, let's say, 3, 5, and 6. He has 3 operations. You are asking the child to create highest possible number. What happens in this activity is, generally, I have tried this activity many the times in the classroom. And what happens is, the slow learners perform the best because they hardly get time and chance to answer in the class. But if you give these type of activities, the real talent comes out. So if you are, let's say, giving them, asking them to just using three digits, 3, 5, and 6, and three operations, you can use any two operations and just arrange the digits. So what is happening over here? They are doing strategy, like strategy building is happening over there. And second thing is that problem solving is also happening over there. Some kid might use 6 into 5, other might use 6 divided by 3. So it depends, and there are many possible combinations, many possible answers that can come. So it's not restricted to one answer, rather multiple answers can also come. And at the same time, you are teaching the students one of the most toughest and trickiest concept of mathematics, which is word mass. Like, I am covering DMAS over here. I just gave you the idea how this activity can work. You can even put parentheses, you can put off. Complexity can be decided based on the grade level. Digits can be decided based on the grade levels. So this is one of the activity which you can again do with your kids in the classroom to see that, like, how the real learning is happening. So this is what I wanted to present today, share with all of you, like few of the learnings, few of my learnings, and few of the activities that I have made. And yeah, thank you so much for being so interactive, for answering all the polls. And I can see still there are many messages in the chat box. So I would just like request everyone, so please share your valuable feedback. You can scan the QR code and you can submit your feedback. That's a very short Google form. You can just fill your feedback. Thank you so much.
So, to all the participants, you can fill in this feedback that ma'am has shared. But just a clarification here, this feedback form will not give you any certificate. We will be sharing the feedback form by Monday on your registered email ID, by filling which you will receive the certificate. This feedback is for this specific session only. And to all the participants, chat box is open for any questions, concerns, queries, if you have any, for the discussion that we had done so far. We are just receiving positive feedback from all the participants, ma'am. I hope everybody has filled the feedback form also. And again, if you have any questions or concerns, please drop it in the chat box and we'll pick the questions.
Instead of writing all your feedback on the chat box, I would really request all of you to please fill this feedback form. It will really help me improve my further session. So if you can, please scan this QR code and take your time to fill the form. Thank you. And obviously the floor is open for questions. So if you have any questions, please feel free to ask.
We have received only one question, ma'am. Ms. Nidhi asked, any activity related to LCM?
Yes, there is an activity related to LCM, and I always do this activity with Jenga blocks, which are kids' favorite. If you are doing it, like, I'm sure there must be government teachers also, and if you don't have these fancy materials like Jenga blocks, what you can do is you can use लकड़ियां, जो पेड़ की टूटी हुई छोटी छोटी लकड़ियां होती हैं, अगर आपको एक बड़ी लकड़ी भी मिल रही है, just try to broke it into different pieces, and then like you can just do the activity. I'll just quickly take this activity. Let's say you have to why I'm not getting the option to annotate? Initially I was getting, but now okay, got it. Yeah, so let's say, Nidhi ma'am, you have to find the LCM of 3 and 4. So all you need to do is, if you have Jenga blocks, let's say I'm considering rectangular blocks over here, just ask the kids to make as many groups as they want of 3. So I'm just consider these as Jenga blocks. Please don't go what I am drawing. So let's say I am drawing 3 के groups में मैंने कई सारे, let's say groups बना लिए 3 के, and I stopped here, let's say. Now similarly for 4, again I have made groups of 4. I'm just making, okay, now I'll start making this. Now you can see, all you need to ask your children is, at what, like after how many, the number of blocks are equal in both the groups. That means here 3, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Here what is happening? 4, 4, 8, 12. Now if you remember, we got 12 here also. You have to consider complete blocks. 1 group, 2 group, 3 group, 4 group. Stop here. Again, 1, 2, 3. You got 12, you got 12. That means as soon as in the complete groups, you got the numbers same, that is the LCM of that number. So 3 and 4 has LCM 12. So this is the activity that I frequently do with the teachers, with the kids, and you can also try it in your classroom.
Great. So I believe we are towards the conclusion of the session now. Thank you so much, Divyanshi ma'am, for such a wonderful session. It was truly inspiring and full of activities that all the educators can implement in their classroom. For tomorrow, I would like to mention once again that we have a quiz scheduled after the last session, that is after 5 p.m. So make sure that you are also signing in for day 2 of Mathematics Summit. We have another good lineup of exciting sessions. So I'll see you all tomorrow. And Divyanshi ma'am, thank you so much for